Swartwood students?
Hell yeah!
Hi guys, we love to keep the reviews going, but with MCAT classes getting so big and with the schedule getting really hectic, it's harder and harder for me to get out there and run reviews, and it's harder to arrange reviews. So basically, I guess the compromise is this. We're going to go to a video format, try to help out with homework problems, so on. You know, it may be a little while before we actually get live reviews on there, but eventually, hopefully, everything will work out. Okay, so either a live video streaming review or maybe pre-recorded reviews, whatever it turns out to be. For the moment, right now, we're just going to do a couple of problems because we had some requests. So let's get that out of the way and maybe get a little bit of work done. Okay. So one of the first things I want to look at is there was a kinematics problem, and I think it's something like this. So they mentioned there's some car, I don't know, some car doing maybe this thing. That's a pretty horrible car, but you get the idea. So let's make it a little more sporty. Okay, some sort of car here, and then there's another car, and they're zooming by. One car zooms by the other, so maybe this is more like some sort of bug or something. I have no idea. So maybe something like this. Okay, and maybe on this setup with this car, what's happening is this car zooms by, so they're both zooming along. This one just passes that car, and this guy happens to be going maybe 25 meters per second. Okay, this other car, when they pass, right, is going at say 20 meters per second. Okay, well actually, you know what? Let's make the numbers a little more interesting. Let's say 10 meters per second. So the question is now going to be, when this guy zips past that guy, right? The thing is that this guy will constantly be going at 25 meters per second. So he's not speeding up. And even though this guy is slower, the second that guy passes him, he's going to hit the gas pedal and he's going to start to speed up. Okay? So let's say he has an acceleration maybe 2 meters per second. Okay? So both guys are zipping along, 25 meters per second, 10 meters per second. This guy's running at 2 meters per second because now he's putting his foot in a gas pedal, and he's going to speed up a little bit. Okay? So my question for you is this. If we start the clock at time equal to 0, right when this car passes that one, how much time is it going to take for this car to catch up to that one? Okay? And it's pretty mellow, right? So our thinking is this. Well, what are the facts you know? When this car overtakes that car, right? When they line up just right, so when they're at the same place at the same time, well, the timing is going to be the same. It'll take the same amount of time, right? Because this guy will do something, that guy will do something, they'll meet. They started at time equal to 0, so the time will be the same, right? There's also another thing, though. The position will be the same. So maybe the easiest way to look at it is wherever they meet up, we don't know where that is right now, but wherever they meet up, obviously the position they meet at is going to be the same, right? Okay, so let's just compute it separately. This guy's probably more mellow. You know, he ends up somewhere. So where you end up is where you started, plus velocity times time, right? Okay. There's no acceleration because he's going at a constant speed, okay, or a constant velocity in this case. Okay. Then let's run it for the other guy. The other guy's got the same thing. Where you end up is where you start, plus velocity times time. The only difference is this guy's accelerating, right? So you got to put that in there. So that's our 1/2 AT squared. Okay, no big deal. A couple things to note. So 2 important facts. Fact number 1, the thinking is more important than just crunching the dumb equations, right? Got to think about it first. They will be, when they meet up, right, they will be at the same place, and of course they'll be there at the same time. Okay? That place is encapsulated right here with the x final. These guys will be the same, right? The time just implies that this time and that time have to be the same. Okay? With those restrictions, we can actually solve this, right? Now it's this piece of cake. We're going to plug and chug it. Okay. So let's plug this in. So we don't know where the final position is, but we know when we get there. By the way, the initial position, we'll just choose it right when they pass one another initially, right? And we'll call that 0. We're allowed to do that. So we can say the starting position is 0. No big deal. So that makes our equations a little bit easier. Then where does this guy end up? So the 25 meter per second guy, he's going at a velocity 25 meters per second. He's going to run for some amount of time, and that will be his final position. Everybody agree? Okay. The other guy, the guy that's speeding up now. This guy is going to be, where he ends up, is going to be what? His velocity, which is, I think I erased it, my bad, 10 meters per second, times the time he travels for, which will be the same amount of time as this guy, plus 1/2 AT squared. Or we're told the acceleration happened to be, again I erased it, my bad, 2 meters per second, and it's t squared. So this guy over here, it's got to be x final. So that part is just plug and chug, right? We plugged into this equation, velocity times time, got it. We plugged into this one, velocity times time, plus 1/2 acceleration times time squared. That's just right here. There's no work there. We're just plugging in. Then the thinking is you're at the same place at the same time. So when you meet up, right? When this guy overtakes this guy, they'll be at the same place at the same time. So these equations have to be the same. So now it's a piece of cake. It's 25t is 10t plus, well, why don't we just do this? 1/2 times 2 is 1, right? Plus t squared, okay? And again, there's two possibilities. I think the easiest thing is just divide by t, right? Technically, you have to be careful because you might be dividing by 0. We already know that time equal to 0 is not of interest to us, right? Because we don't care about when they cross each other. We already know that the first time. What we care about is when the slower guy speeds up and overtakes that guy. That's the time we care about. And that's obviously not at time equal to 0. So we can divide by t. And then it becomes a piece of cake. It's 25 minus 10 equal to t. So this has got to be what? 15 is equal to t. So I guess it takes 15 seconds for this guy who's speeding up to overtake that guy. Okay? No big deal.